Question 3 for 14 marks. Use mathematical induction to prove that 2 to the power of 3n minus 3 to the power of n is divisible by 5 for all n elements of natural numbers. This is either going to get you the easiest 14 marks in AP Maths, or you are going to blow your A star right here. First, a note on mathematical induction. It is a property of the natural number set. It makes sense when laid on top of discrete positive numbers. We can prove a hypothesis based on the algebra of natural numbers. Step 1. Prove the result is true for n equals 1. It can be any natural number, but 1 is often the easiest to prove. Step 2. Assume the result is true for n equals k, where k is a natural number. Step 3. Based on step 2, prove that the result is true for n equals k plus 1. A simple analogy to real life would be that to climb a set of stairs, you must first be able to climb onto the first one, and the second step, assuming you are on the stairs, you must be able to climb to the next one. Another common example is that if I am going to flip a set of dominoes, I must be able to flip the first one, and then I must know that if I flip the nth domino, it will also flip the n plus 1 domino. Step 1. Take our problem and assume n equals 1. Then we have 2 to the power of 3 minus 3 equals 5, which is clearly divisible by 5. Step 2. Assume that it is true for n equals k. Then 2 to the power of 3k minus 3 to the power of k equals 5p, where p is an element of n, the natural numbers. Step 3. If n equals k plus 1, we have 2 to the power of 3 times k plus 1 minus 3 to the power of k plus 1, which equals 2 to the power of 3k times 2 to the power of 3 minus 3 to the power of k plus 1, which equals 8 times 2 to the power of 3k minus 3 times 3 to the power of 3k. From step 2, 2 to the power of 3k equals 5p plus 3 to the power of k. Substituting in 8 times 5p plus 8 times 3 to the k minus 3 times 3 to the k equals 5 times 8p plus 5 times 3 to the k, which equals 5 times 8p plus 3 to the k, which is clearly divisible by 5 because 5 is a factor. So, by the principle of mathematical induction, we have proved the result for an element of natural numbers.